Okay, so revisiting the Von Hale uh, uh, geometry um, levels, we're going to first look at level 0, recognition. So activities for so there are a bunch of activities that they mention that you can use to help the children develop this being able to recognize uh, different shapes. And so the first one that they talk about is looking at tiling patterns. And so, for example, here's a couple of examples of tiling patterns. Of course, these occur all around us. You could usually look at the floor of your classroom or the hallway or a student's home. And there are all sorts of different tiling patterns that show up. And one fun activity would be to be able to recognize different shapes in these tiling patterns. So you might look at this first one, the orange and brown one, and say, okay, well, there are a bunch of squares that show up in this tiling pattern of various sizes. Oops, I did not need to move that. There we go. That look like this. There are some larger squares that look like this, and even like this. So you can recognize squares of different sizes. You might also be able to recognize rectangles of different lengths and widths. Right, so some obvious ones here. And you may also recognize other parallelograms that aren't necessarily squares or rectangles. So there are definitely triangles that show up here, right, of all different shapes and sizes. Let's see, I think there's one like this. Great. And I think there are even some 1, 2, 3, 4. Wow, I'm seeing how many sizes does this figure have? I have to count it here. Let's see here. Let's see. If I go by these smaller gray lines, that's got 1, 2, 3, 4. Oops, shouldn't have drawn it there. Let's do it here. 1, 2, 3, 4, 5, 6, 7, something with 8 sides. There we go, an octagon. I was like, how many sides is that? We have octagons and all sorts of different shapes in this one tiling pattern that we can pick out. I think we can pick out some larger octagons as well if we wanted. And then in the tiling pattern on the right, we have even more new shapes that we can get, right, just by kind of tracing different parts of the tiling pattern. Different rectangles of different dimensions, other different rhombi and triangles, and so on. Great. So tiling activities are helpful for students being able to develop this level 0 ability of recognizing different shapes. Students may not be able to recognize different shapes based on their orientation. So we kind of saw this in the previous explanation of the different steps when a student may not originally notice that this is actually a square just because of its orientation. They might be used to seeing something more like this as a square, okay? So that's something to keep in mind and kind of test the bounds of at this level. And these tiling patterns are good for doing that, right? Because they get to the students to kind of see more shapes than they're used to in different configurations. Okay, so another good activity at this level are called sorting activities, which we've seen a lot of. So these can be done with objects that they can actually manipulate. So blocks or tiles are very helpful at this stage, especially because that helps with this idea of orientation, right? So if I take a tile, if I take a triangle tile and I flip it upside down, it's still a triangle, right? So it really helps with that orientation concept. Okay, so for example, if I have this batch of shapes on the right here, I can sort them in a few different ways. So I might start off by sorting them into into two categories. I can sort them into triangles and quadrilaterals, or things with 3 sides and things with 4 sides. So I can pick out all my triangles and I can put them into one group, and then I can pick out my quadrilaterals and put them in another. And then from there, I can even sort within each of these 2 groups or categories, right? So the triangles, I could break up into isosceles triangles, which have 2 equal sides, or 2 sides of equal length, and equilateral triangles, where all 3 are the same length. And then I can take this second category and I could also try to finer tune, divide this up into smaller categories, into things that are rectangles but not squares, and then things that are squares. So we'll go through, I think it's in the next section, or 2 sections, kind of reviewing some of these definitions of these subtle distinctions between isosceles and equilateral triangles and so on. But now we're just kind of talking pretty broad strokes. Okay, so another really good activity at this stage for being able to recognize shapes is working with what's called a geoboard. And a geoboard is basically just some sort of grid with pegs, and that you use rubbered bands on the pegs to create different shapes. So here, I believe these are rectangular geoboards, but there's also examples in the book with triangular geoboards, where the arrays of these pegs are in slightly different arrangements so that you can actually more easily make triangles and such. But these rectangular ones are good for equilateral triangles, or isosceles triangles, and rectangles and squares and so on. Okay, so for example here, looking at this example 12.13, on a geoboard we can construct isosceles triangle, an equilateral triangle, a rectangle, a square, a parallelogram, and a rhombus. If not, say it's not possible. So I think that, so here are, here's an equilateral triangle, and here are 2 isosceles triangles. Here are a few examples of squares and rectangles, and here are a few examples of rhombi. I think that's the plural of rhombus. Rhombi? I would think so. Sounds weird to say out loud though. Okay, great. Another, buying a fancy geoboard is not exactly necessary. This can also be done on square dot paper or lattice dot paper. A student can just draw these shapes connecting different dots. Okay. All right, so here's a little example that's something similar to the homework. This is number 8 at the end of the section. So we're just identifying some of the figures in this shape. So the first thing to identify is a square, and there's probably more than one here, but the one that's very obvious to me that I'm seeing, kind of ignoring the fact that my picture of my page was a little bent, looks like this is a square. I would probably label my answer by referring to each of the points. So there's the square, Q, O, F, H. So all these vertices that are connected. So a rectangle that is not a square, well, I think there's, again, probably a few of these. It looks like this is a rectangle that's not a square. In fact, the whole thing is also a rectangle that's not a square. So I would call this, again, kind of up to you how you were going to label it, but maybe A, D, P, K. Or if I were talking about the whole thing, I could call it A, E, G, J. And I'm just putting a a little square slash rectangular thing in front just to let myself know that it's the shape that I'm referring to, that I'm not just referring to those points or something. A parallelogram that is not a rectangle. Okay, a parallelogram that is not a rectangle. Let's see. So here is one that I see. You might have seen a different one. These here, my sides are parallel. Oopsies. And so this would be, oops, trying to draw a parallelogram, but it's not great. K, Q, H, I. Looks like a parallelogram to me. I'm trying to see if there's another one that I'm missing. That's pretty obvious. There's probably another one in here, but I'm not seeing it right away. So you can probably identify more. Oh yeah, here's another one. There's one too. So they just asked for one, but I'm just giving a couple in case you see different ones. K, M, O, Q. An isosceles triangle with no right angles. Okay, so isosceles triangle means two of the sides are equal length and it has no right angles. So I think this is one. So MCO. And I also think this is one. So that would be the points of this one are M and O. Are there more? Oh, here's another one, I think. It's also an equilateral triangle, it looks like. Oh, but it looks like it has a right angle, right? So that one actually doesn't count. This one also has a right angle, so that would not count. There might be another one here, but I am not seeing it. Oh wait, no, this one. So and M S O. Okay, and the last example wants us to find a rhombus that is not a square. Okay, well this. Let's see, erase this. This guy is a rhombus that is a square. Okay, so we need equal length sides, but not right angles. So it looks to me like this one would be a rhombus that's not a square. So that's MNOS. For these labelings, it doesn't matter what point you end or start on. And is that the only one? Great. There's probably, looks like this one might be up for interpretation. It's a little hard to tell. I think those are equal length sides though. So I think that one counts. And let's say KMOQ. I think that one looks like it. All right, so in the next section, we'll talk about moving from level 0 to level 2. Or sorry, level 1.